Hi everyone, welcome to the next lesson. So this is my favorite subject, that is assembly. So Fusion 360 assembly is completely a new environment where you will get access to top down and bottom up both the method to create your assembly. And the best part, as I mentioned in the earlier lesson also, Fusion 360 doesn't have different file format. So everything is on the same file format, which is F3D. So assembly part all on the same platform, same screen. So how we are going to assemble components on Fusion 360. So first we are going to create assembly with the parts. Okay. So already I have a couple of parts, so which is part of a arbor frame. So I'm going to show how we can import those parts to Fusion 360 screen and how we are going to assemble the same. And all these parts, I'm also going to share it with your faculty members, which will be uploaded to the same platform where you are going to access these lessons. And please download those files on your desktop and you can follow the same step as I show on this screen, right? So before I start assembly, first thing I need to import the 3D files to my Fusion 360 project. So I'm using this dashboard again. So inside the dashboard, we are inside this IIT ED project. So for this particular assembly module, I'm going to create a new folder where I can upload the parts. So I'm creating new folder. This folder name, I give it as Arbor frame. So this is my assembly. So inside this particular folder, once I open, I can upload the 3D parts. So which are these 3D parts? So it can be from any software or any common 3D file format. So whether it is SolidWorks, ProE, CATIA, or even AutoCAD 3D model, you can import to Fusion 360 and all those parts put together, you can bring it on one single screen to assemble. So to upload those files to Fusion 360 on the top, once after you open the folder, here you can see the upload option available. Clicking on this upload, I can select the file or I can drag and drop the file from the folder. So here you can see all these files. I'm going to share it with you. I'm selecting all the files here. Okay. And I'm just going to drag and drop those files inside my Fusion 360 screen here. And then I can just select upload. All these files will be uploaded to your Fusion 360 project. So this will take a couple of seconds. As I mentioned, meantime, so like for example, I'm going to design a car. So I have about 100 components which are designed using SolidWorks software. About 50 components I have used CATIA. Another 50 components I have used some Unigraphics. So all these components you can just directly upload to your Fusion 360. So now you can see the upload has been completed and all these files you can see here, this is the F3D files. So once after selecting close here, you can notice. So these are the components which I have uploaded to my folder inside the Arbor frame folder. And I'm going to start bringing all these components to my Fusion 360 screen to assemble. So before I bring these parts to Fusion 360 screen, first we have to save the file. I'm going to save this file inside the same location, IIT project and Arbor frame. So this file name, I give it as Arbor frame assembly. Once after selecting save, now, so here you can see the same file has been uploaded to the project. So this file is saved. Now I can import components to my screen. To get the components on screen, you can right click on the component and here you can select insert into current design. That means the active file. So whenever we work on assembly module, so it is always a best practice that the biggest component we import first so that we can assemble the small components one by one. So in this case, this arbor frame is the biggest component in this particular assembly. So I can right click on this file, and here I can select insert into current design. Once after I select insert into current design, so here you can notice the same component on the screen, and it is also giving you option to move the component left, right, top, front, back. So in any direction you can move. By default, it will be inserted at the orientation 0. So I don't want to move this anywhere. I can just select OK. So this component has been inserted inside my arbor frame assembly. So the next step here, you can notice that component here, it is showing the link symbol. That means this component is not created in this file. So this is a separate file, and this file has been linked to assembly. Whenever you edit the main file, automatically your assembly will get updated. Okay. And second thing, when we are supposed to assemble something, for example, like I'm just trying to show my water bottle. So I need to remove the cap of this water bottle first. I have to hold the bottle first, then I can remove the cap, right? So without holding the bottle, I won't be able to remove the cap. It will just rotate the whole body, right? So what I'm trying to do here, first I need to fix this frame so that I can assemble the remaining component and I can ensure the relative motion here. So to fix this component to the screen, you can right click on the arbor frame component on your browser. Here you can find option available ground. So select ground. Now this component has been fixed. You can see the symbol here, pin symbol. And if I try to move this component, it won't move. This has been fixed to coordinate 0 here, right? And now I'm supposed to bring the second component, which I'm supposed to assemble here on the top of this plate here. So I'm going to bring this table plate component to the same assembly. Right clicking on this table plate, again, I can select insert into current design. Okay, I'm just moving this component a little outside so that I can access the points here. So selecting OK. So now this table plate is here. So what I want to do is I want to fix this table plate on the top of this. The purpose, so this particular gap here, so which will help me to fix the pipe or something, right? So when I bring this table plate on the top of this frame, these two circles should align properly at the center. At the same time, the purpose, I should be able to rotate this plate. Okay, that is the relative motion, what I'm expecting. So I'm going to select inside this assembly tab here, you can find joint. So here you have shortcut also, you can just press J, or you can select joint, or here also you can find the same icon. By selecting joint, now you can notice the fixed component turned transparent. So it is highlighting you are supposed to select this second component to insert, right? So I'm zooming this particular component here. You can notice if I move the mouse, software is highlighting so many points, nodes here to select. So I can select any of this depending on my requirement. So here my requirement, I need to select this center. I want to align these two components exactly at the center axis. So I'm selecting this center. Now this has turned transparent and the fixed component it is highlighting here. Now here also it is giving a lot of options for me to select, but I'm selecting the same center here. Once after selecting these two components, you can notice, so software exactly fixed this component over here. And here on the right side, you can find the joint dialog box where you have all the options available. So first one is mode, a simple joint, which you have selected. Next, you have between two faces or you have two edge. So depending on your selection, software will highlight this particular thing. So mode, so right now I have selected to center. And so here you can notice you have options available to give the offset distance, X, Y, Z. So in whichever the direction, for example, most of the time in our mechanical design, we prefer to give the clearance. If you are supposed to give clearance in that case, on that particular direction, you can give the offset distance. So in this case, I don't have to give the offset distance. But now, if you look at this, so this is a rigid joint. When I select these two center, software has fixed this table plate. So this table plate doesn't have any relative motion now. To give the motion, so here on the top, you can see the motion tab available next to the position. Selecting this motion, by default, software always make it as rigid. So this is not a rigid joint. As I mentioned, I should be able to rotate this. So here I can change the type of motion. That means the relative motion. So rigid, revolute, you have slider, then you have cylindrical. So it will be fixed, but it can slide up and down. Then you have pin slot. Only the center will be fixed. It can rotate, it can slide. And then you have planar. Then last one, you have ball joint, nothing but tangent. So in this case, I'm going to select revolute. You can notice, so this is the relative motion between these two components. This component can rotate within the same axis. And if you have to change the rotation axis also, you can change it here. For example, right now, software is intelligent enough to understand it should rotate in Z axis. In case if you want to change, you can change it like this. So X axis, Y axis, also whichever the axis you want. So default software will understand the proportionate axis, so it can rotate, and I can select OK. So I have assembled two components. Now, if I try to move this component after the joint, so you can notice software will just rotate this component within the same axis, depending on the availability of the relative motion. So it will just rotate within the same axis. Clear? So the next one. So I want to bring this faceplate. Selecting this faceplate, right click. I'm going to select insert into current design. So I'll just move this a little bit outside. Okay. So now this faceplate, I want to fix at this location. So here you can see option available to insert 4 screws. That means this will be a rigid joint. So there won't be any relative motion, but I just want to bring this particular faceplate exactly here. So again, I'm going to use joint. So capture position. So whenever it asks, so as you have moved this component outside the or coordinate 0, so I just select capture position. So say here, I'm going to select to center. So this whole center, I'm going to select. So let me just repeat this. Assemble, capture position. Sorry, so there is some lag. So I'm just moving mouse so that here also you can notice software is highlighting all the available options. So I'm just selecting this center. Then I'm selecting this center on the frame, right? So again, you can notice software is going to fix this faceplate, but it is rotating because the previous motion, which I have given revolute, it will just continue the same. I will change it to rigid, okay? And if you want to see the animation, so again, you can click on this animate. It will keep animating until you stop so that you can realize the relative motion between the components. So then you can select OK. So this is a rigid joint. Even if I try to move this, you can notice software will not allow me to move this component. So now the next step, it's inserting the screw. Now the biggest challenge, so all these standard components, whether we should again design or create a 3D model, or we can use the available source and insert. So here we don't have to waste time on designing standard components, which is like a nut, bolt, screw, washer, bearings, chain sprocket, gears. So these kind of standard components you don't have to design again. So Fusion 360 will allow you to get all these components from a standard website. So if you go to insert, inside this insert, here you can find insert a manufacturer part. Okay, selecting this insert manufacturer part. So software will go to a website where you can notice. So inside this website, you can notice all the companies worldwide. So you can search component based on these companies. Okay, so millions of components available here. So you can search based on the company name, or you can search based on the component name. All you have to do is you just have to enter here. For example, I want to enter, this is M4 socket headed screw, M4 socket headed. So I can just search for this component. So here I just have to search, it is not highlighting screw. So maybe like I can search socket headed screw, right? So it is available from so and so company. So you can search this based on the available company in your region, right? So I'm just selecting socket headed screw here, ISO 610. So once after selecting this, here you can notice software will show the preview of the component on your browser. Sorry. And here the size available. So this size is M12. So this is too big. So I cannot use this one. So I'm going to search for the different one. Let me just go back. So maybe this one. So let me see whether the size is available. So this is M6. So let me just, I'm not sure about this size. So this should be like, so this is actually supposed to be M4 only, but I'm not able to find. So M4 screw. Okay, so these are the different screws available in M4. So I just have to search for this. So without wasting time, I'm just going to select some screw. So later you can find it out. So this is the screw I want to use here, right? You can see the preview. And then I'm going to select to Autodesk Fusion 360. So if it is first time, you might have to log in to this website, use the same ID and password, you can log in. So I'm just going to click on this to Autodesk Fusion 360. So it is asking me for my login ID. So once after I log in, so here I can just select to Autodesk Fusion 360. So It will ask you whether you want to launch the application. So just you can select open Autodesk Fusion 360. So here you can notice the same component available on your Fusion 360 screen. Okay, so here it is. So this one I'm going to insert to the location where I'm supposed to. So again, I can go to join. So capture position. I'm going to select this circular face just after the screw head. So I'm selecting this circular face here. Right? And I'm selecting this circular center. So here you can notice sometimes there is a challenge here. So this is in the reverse direction. But if you want to change, so inside this joint dialog box here, you can see there is an option available, flip. So I'm going to flip this, right? So size is something different anyway. So I can select OK. So this is how you can import the proper component from the website. So here, as I mentioned, millions of standard components available in the same website. So you can search for the component and you can insert to your Fusion 360, right? So the next component which I'm going to insert here, so that is the collar. So this collar, I'm supposed to insert at this location here, right? So before I bring the pinion shaft, so I'm inserting this collar. So insert into current design. So here it is. So very simple again. So most of the 99% of the time in our mechanical design, so it's all about using nut, bolt, screw, those kind of things. It's all about using the center. So same joint, I'm selecting this circular face, and I'm going to select this circular face here, edge, right? And it is going inside. As I mentioned, we can just click on this flip icon to bring it outside. And I can select OK. Before that, okay, the type, this should be revolute. Okay, so it should rotate within the same axis, and I can select OK. And the next thing, so I have to insert this pinion shaft. So right clicking on this pinion shaft, insert into current design. This is again very simple. Same procedure. So join, I'm going to select this pinion shaft. So inside edge of this chamfer, because the chamfer portion should be outside the collar. So I'm selecting this inside circular edge of the pinion shaft, and I'm going to select this collar edge here. Okay. And the motion, it should rotate within the same axis. So by default, the motion, it is revolute because of the previous selection, and I can select OK. And the next thing, I have to insert this lever arm to rotate the pinion shaft. I'm going to insert this. Again, very quick. So, but here there is a small challenge. This lever arm should go exactly at the midpoint. This mid of this lever arm should go exactly here inside the pinion shaft. So what I can do, if I go to join, you can notice when I move the mouse near this cylinder, software is also highlighting midpoint of the cylinder. You can notice here. So I'm selecting this midpoint or this center of this mid of this cylinder and the center point. And I'm going to select this pinion shaft, this circular edge. Okay. So this is again rotating within the same axis, and I can select OK. Now there is a relative motion. If I try to rotate this pinion shaft, you can notice. So this lever arm will also rotate along with that. Or if you try to move the lever arm, so together, so this pinion shaft will also rotate. So this is the relative motion between the component, which will help you to understand the mechanism, what exactly you are trying to do, and the relative motions. So last but not least, I'm going to insert this RAM. So here is a big challenge. So I'm going to bring this lever arm on the screen. So my requirement here, this lever arm should go exactly inside this space, okay? And the gear, this gear should face towards this particular face so that it can have connect with the pinion shaft, right? And all these side edges, it should align to the frame here. And how we are going to exactly insert this pinion shaft inside this. So sorry, this RAM. So basically, like in the previous softwares and all, we used to give the constraints, multiple constraints. But in this case, Fusion 360, so I'm selecting joint, capturing the position. Here you can notice, if I move the mouse on the top of this face on the RAM, okay, you can notice software is also highlighting the midpoint of this plane or this rectangle face. I'm selecting this midpoint, okay, and I'm selecting the midpoint of this frame here. You can notice here. So I'm also selecting the midpoint of this frame. Okay. Software has inserted the RAM here, but it is in horizontal direction. It is supposed to be vertical. So what I can do, as I mentioned in the previous component, so we can give the offset distance, but here we can also give the angle. By default, it is showing angle minus 90. Okay. And I change this to 0. Now we can notice, so this RAM has rotated to vertical direction. And the next thing, the motion, it should not rotate, it should slide. So what I'm going to do, I will select this option here, slider, in the motion. But again, the problem here, it is sliding front and back, but it is supposed to slide top and bottom. So what I can do, the slide, you can see the axis, default it is showing Z axis. If I change it to X, it is sliding left and right, or I can select Y to make it vertical. So one single joint. So I managed to get the result, what is expected here, and I can select OK. So you can see the relative motion here between these two. But now the problem here, so this RAM, I have given joint between the RAM and frame. So there is no joint between the RAM and pinion shaft. So as it is gear, you won't be able to give exact relative motion between these two. Or you cannot be able to create joint between the gears here until unless if it is a standard gear. As this is a component which we have created, so what I can do, software will give you an option here. Inside assembly, here you can notice motion link. That means manually you can provide the link between the components if it is not using joint. If it is using joint, you can see the relative motion between this pinion shaft and the lever. But in this case, there is no relative motion between these two. So I'm going to give the motion link between this pinion shaft joint, this circular pinion shaft joint, and this slider. I'm selecting these two, this revolute joint and this sliding joint. I have selected both together. You can select here. If you have confusion, you can select from the browser. inside the joint folder, you can see all the joints available. You can select from here also. And how much it should move or rotate, so that you can specify depending on the experience here. So I can say like if it is rotating 360 degree and the RAM should slide distance 55 millimeter. Okay, I can select OK. Now you can notice if I try to slide the RAM, the pinion shaft will rotate, or if I try to rotate the pinion shaft, the RAM will slide. So 360 degree, it will slide 55 millimeter. So this is the joint I have given between these two components. Okay. Now, last but not least, so it is also important to understand the contact set. For example, if I'm moving this, if I'm trying to move this RAM towards down, you can notice the RAM is just passing through the table plate. So actual requirement, it should exactly stop here. It should not go inside. But so we have not given any type of information to software, right, to stop between these two components. So here you can notice inside the assembly, we have option available, enable contact set or enable all contact set. I never suggest to use this all contact set because normally in our mechanical design, we don't consider the clearance between the components, because as per reality, there shouldn't be like a complete contact between these two phases. There should be a clearance, but while designing, we don't give that clearance. So I don't suggest to use this particular option, enable on contact set. Rather than that, what you can do, you can select enable contact set. Just clicking on this enable contact set, software will activate the contact set. Once after activating the contact set, here, now you can find new contact set. After you activate, so now you can see the new contact set. Manually, I can give contact set just between these two components. If I say all, it will consider between all the components. I don't want that. So I have just enabled and manually I am giving contact set between these two. After selecting OK, now you can notice if I try to slide this RAM, it will exactly stops at this location. It is not going beyond this point. Okay. And the best part with Fusion 360, after creating all these things, here you also have an option, so which is motion study. So when it comes to robotics, when it comes to machine design and machine study, in that case, so this motion study will help you to understand the motion or relative motion between the components depending on the time frame. So for example, I want to study the motion of this particular pinion shaft. If I just click on this joint, you can notice software is going to highlight the joint in this red color line here. And this is the duration. For example, if I select from 0 to 10 seconds, I want this pinion shaft to rotate 180 degree. And next 10 seconds, I don't want any changes. I just want to leave like that. Next 20 seconds, it should go back to 0. And next 20 seconds, it should go to 270 degree. Next 5 seconds, I don't want any changes. Okay, so this is 65. I can type also here. So no changes. And again, till next 25 seconds, I want this to go back to 0. This is how I want to see the animation here. After providing that, you can select this repeat function here and you can change the speed. So I'm just reducing the speed and I can select play. So as we have already given the motion link between the pinion shaft and the ram, so even though if I'm going to study the motion of this pinion shaft revolute joint, so still you can notice here this ram is sliding. Okay, like this you can bring multiple component even if you want to bring this table plate. So table plate is also here. So this also I can give like a 180 degree, it should rotate. Then you should go back to 0. Then you should go to 360 degree. And again, go back to 0. And I can, now you can notice while playing this, so all these components are animating together, but here we do not have any option to record this animation, but using any third-party application, screen capture, you can record this video. So this will help you to understand the mechanism. And when it comes to robotics also, this is very, very useful function, and you can adopt this completely. So with that, so I'm going to share all these components with you together with the lesson. And I hope you should be able to assemble all these components and explore the possibilities. And you just don't have to try the same thing if you want to explore with a different motion study and all. So please try that and make sure that you have this assembly completed. And so yeah, so and make sure you are going to save this file. I'm also going to save this file so that we can use the same assembly file for the animation study also, or we call it as exploded view, that we can see it in the next lesson. Okay, so all the very best. So please try to complete this exercise and make sure that you have saved the file. Okay.